Hello.
Hello, Uncle. Happy Diwali.
Oh, Nandrima. Happy Diwali. Okay, good. We are working on Diwali. Good. So, okay, let me first get the whiteboard. So we were looking into integration, right?
Yes, yes,
But you have the good understanding of why we are doing any differentiation and how we can recover that by the inverse operation
yes,
is the integration. Okay. So
yes,
always when we learn the maths with the application and the actual meaning, that will make us to think, analyze everything in a much better way. And also we don't need the revision or something like that. Like we will step back and ask the right question to help ourselves to get to the point. Okay.
yes, yes,
Always do that. So don't just take it granted, like, okay, I have been told so by teacher or myself or the textbook or something like that. You have to question to the level. Okay, always stepping back is not a problem, because only when we have that strong foundation step, from there only we can build up the steps which are above that. Okay.
okay, yes,
Everything are playing their own important role, and we need to be clear with what is the meaning for that and how they are going to help us. Okay, can you see the whiteboard?
yes, yes,
Okay, so uh, so we did I tell you that counting the sheep numbers example for the differentiation?
yes, 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 sir.
Okay, so
Mhm.
something like, if the function is something like a x squared, then we know that x squared itself is x multiplied with the x, and the number is 2 times. Is that okay?
Yes, sir.
That leads to finally what we did. If you want to find the change happened to the y with respect to the change in the x itself, we just substituted the y function value here, and then from the x point of view, differentiating variable point of view, we found that there are x's available, but it is in the form of multiplication, right?
Yes, sir.
So that leads to our keep one of them aside and deal with the other, and keep other one aside and deal with the other. Okay. So
Okay, yes,
this is this one, and then this is this one. And once that is done, we kept the other one outside, and then the first one got differentiated. Is it okay?
yes, sir.
Leads to twice x dx by dx, and dx are same variation. So that is why the answer become a 2x. If the same thing, in generically, if you have y equal to x raised to the power of n, then we would have done the same thing. Like, what is dy by dx? We would have just d by dx of x raised to the power of n. Then, as long as when you look at from the x point of view, the variables in the function are in the base level, and this is a constant. That is important. Do you get that?
Yes, sir.
If that itself become let's say it is a x raised to the power of x, then we cannot do that. Do you get that?
Yeah, yeah, yes, sir.
Okay, so now we are going to keep n minus one of them outside and deal with only one of them. Do you get that?
Yes, sir.
Will get repeated. The other n minus one kept outside and deal with that, and this will continued until n times. Do you get that? N minus 1 dx by dx, and if you count how many of them, there are totally n of them. Makes sense to you?
Yes, sir.
Now we take care of all the n of the x's getting multiplied. So that becomes n x powered n minus 1 dx by dx. Dx variation is same as this, so that become a n times x powered n plus 1. This is, sorry, n minus 1.
Minus.
Why I did okay, n minus 1. Okay, n minus 1. So this looks like whenever we want to, like quick example, if I give you a function y equal to 3x square minus 4 over x square. Okay, so now first get it in the form of comfortable, like base level should be x and the power should be a constant. So that can be, this base is already in the form of x and the power is a constant, minus here it is not in a comfortable position, make it like the base is a x and then power is a constant. You're okay with that?
Yes, sir.
Once that is done, then dy by dx will be very easy. So that will be, we are going to do the d by dx of this complete 3x square minus 4x power minus 2. From the x point of view, there is a addition going on. So we can split this into two different, so that means the d by dx can be multiplied inside. Do you get that? So
Yes, sir.
3x squared minus d by dx of our 4x power minus 2. So checking from this point of view, okay, 3 is a constant that can be taken out from this x differentiation. Also, 4 is a constant that can be taken out, but the remaining function is in the form of x in the base and the power is a constant. That means the 3 is taken out and the power has to be brought to the front and the x power to be reduced by 1. Okay, so this will be
Yes.
4 times our minus 2 and the current power of the x has to be reduced by 1. So that will become 6x plus 8 x power minus 3. Then this is going to be 6x plus 8 over x cube. Is it okay?
Yes, sir.
Whenever when we are doing the example problem, something like that, think about the inverse one. Let's say we know the differentiation of a function with respect to a variable x is actually 6x plus 8 over x cubed. We need to think about how to recover because the differentiation of the function is a non-zero quantity, is not a zero. You get that?
Yes, sir.
That means that gives the understanding that the y itself is a function of x. That's the meaning. Okay. Now automatically comes, because of that we are asking, can we recover the y of x itself? Okay.
Yes, sir.
Okay, so start from there. So we know that let's say the y is some function like that, then we can split that into even equal pieces. Each one of them is our dy. Okay, let's say this is our
Yes, sir.
y function itself, y of x function itself. Then what we are going to do, add all of them, and we don't want the change. We want to put a limit of the dy itself going to 0, as small as possible. This is the definition for the integral dy, which will give you the y itself. Is it okay?
Yes, sir.
So that for that we prepare this whole thing in a way that we can get the job done. So that means we are going to get the dx multiplied on both the side. Then we will have integral dy, which will be the dx can be multiplied inside, and we could do the integration on the whole side first of all as the consideration, because it is the same mathematical operation done on both sides. Okay, this will lead us, the y is actually equal to, this one can be multiplied inside, that will be 6 integral x dx plus 8 integral x power minus 3 dx.
Or minus 3 dx.
We are preparing in such a way that we can handle it straight away. Is that okay? So
Yes, sir.
the opposite operation. So when we did the polynomial kind of, base level is a same quantity as that of the integrating or differentiating variable, and the power is a constant. If that is the case, in the differentiation, we brought the power to the front and then the power was reduced by 1. So we need to exactly do the reverse operation in the opposite way. So the power has to be 6 will be 8. The power has to be increased by 1. Is that okay? Current.
Yes, sir.
And then the new power has to be divided. Okay, so that will exactly compensate what we did in the differentiation. Okay. So
Yes, sir.
8 will be 8, and then the current power minus 3 has to be added with a 1 divided by whatever the new power. Okay. And there could have been some constant that would have been completely lost. Then we need to, in our case, I did not use the constant. We could have had the constant, right? So starting, I could even say that there was a minus 5 by 2, for example.
Yeah.
5 by
Okay.
2, and some minus 5 by 2 or something, and that would come as a minus d of 5 by 2. The change happened to the 5 by 2 with respect to x. This is actually equal to 0. Do you get that?
Yes, sir.
That was lost. So that has to be, we don't know how to recover it. We just keep it as that thing. So in the simplification, this should get back our 3x square, and this is going to be minus 4 over x squared plus c. We see we got the same function what we started. Is that okay?
Yes, sir.
Okay, so in doing so, like, we should be ready to step back and ask the question, what is this particular functional form and what is the meaning of that mathematically? From there, we can do any integration or differentiation. Okay. More
Yes, sir.
exercise will get us more confidence and exposure about, okay, this I can do it with this particular method or something like that. For example, I will give you a function which looks like simply a e power x itself. Is that okay?
Yes, sir.
So now if you want to differentiate this, if you want to find the change happen to this is going to be d by dx of e power x. Is that okay? So
Yes,
from
sir.
this point of view, the base is a constant because you know the e is approximately 2.718 and it keeps going. It is an irrational number. Is that okay?
Yes, sir.
Irrational constant, number constant. Is it okay? And
Yes,
it's a constant value. It is not going to change at all. But it has been said that is repeatedly multiplied by itself x number of times. That is what the meaning of e power x is. So the x is still appearing. You get that?
Yes, sir.
Count how many of these constants are multiplied with each other x times. So definitely there will be a variation happening. Let's say there is only 2 of them, then depending on that. So the x is a variable here, which is available in the power. Okay. So the answer for this is simply the e power x itself. Okay.
Yes, sir.
And then we need to still do the differentiation of whatever the power of the x has to be differentiated. In this case, it is the same quantity, so it can be 1 to 1. So the answer will be simply we can say d by dx of e power x is simply our e power x itself. But remember, the chain rule works. Do you get that?
Yes, sir.
So in the case of, for example, d by dx of e powered ax, then we will do it as a d by dx of, okay, we don't need the d by dx. Okay, we need only the, from the x point of view, the base itself is a constant and the power is a containing a x. Do you get that?
Yes, sir.
This contains the x. This is a constant. This is a constant. Okay. Constant, and this has that variable. So if that is the case, then we know that as long as it is this constant is particularly the e, then well and good. It will be same answer. Do you get that?
Yes, sir.
Chain rule will be d of ax over dx. So that will leave you with a is a constant that can be taken out. That will be a e power ax dx by dx. Then that will lead to only a e power ax. Is that okay?
Yes, sir.
So in the case of integration, let's say somebody has done the job of dy by dx is given as a e power ax. Okay. So how to recover the y of x? Okay, that will be a natural problem. Is that okay? Then
Yes.
do the same thing. Dy is actually equal to a e power ax dx. Then integrate both sides. That is integral dy will become integral a e power ax dx. So a is a constant with respect to the integrating variable. This one is exactly in the exponential form. E, it has to be, E is the base, then it is all well and good. Then we are going to say that this is a, the integration also will be the same answer. Do you get that? Like the differentiation.
Yes, sir. Yes.
But we need to do the chain rule. We need to differentiate the power of the E, but this time we need to divide that. In the case of differentiation, we multiplied the differentiation of the power of the E, but this time we need to divide the differentiation of power of the E. Is that okay? So
Yes, sir.
e power ax over a, then this thing will cancel, then you will get e power ax. Don't forget to add the integration constant. Is that okay?
Yes, sir.
Okay. So if this is going like that, things can be different kind of function. That is what they will be testing or examining us. Let me give you a different example. Like let's say we want d by dx. Okay, let's say d by dx of 2 power x. You see, we know, step back and look into it. First of all, from the x point of view, the base is a constant. Do you get that?
Yes, sir.
And the power of that constant base is related to this differentiating variable. Do you get that?
Yes, sir.
What is the knowledge? Something similar to that we know. We know d by dx of, if it is a e, we know that simply it is a e power x. But in this case, it is not e, it is a 2 power. Do you get that?
Yes, sir.
That looks like, I mean, something, if you could convert this whole problem in this form, then we are well and good. Do you get that?
Yes, sir.
So we have to think about, okay, let's call the y equal to our 2 power x, because we are actually wanting, because of this, we are looking for what is dy by dx. That is the main question. Do you get that?
Yes, sir.
Okay. So once we know, this is called substitution. Okay. Substitution. Because we want to convert the 2 power x into some form of e power x. Then we are good. Makes sense to you?
Yes, sir.
Okay. So for that, what we could do, first, this is in the equation form. Substitution is helping us. First, convert this into the to a logarithmic form. Do you get that? Because we
Yes, sir.
want to change the power 2 to a e. That is what we want to do. For that, first of all, get back into a, so what we need to do to convert this into a log form? What will happen?
Will it be x log 2?
So what is the, okay, whenever you want to convert anything from the exponent form to log form or log form to the exponent form, remember in both form, the base has to be the same. Do you get that?
Okay, okay. Yes,
in
sir.
the exponent
Okay.
form, the base is 2. Then simply apply the log to the base.
Log on both.
Yeah. Do you get that? That will work. But rather, I would say that, think a while. We want to convert the base to e, right?
Okay, yes, sir.
Okay. So I'm just comparing the real action. Like, okay, our target is only want to convert this into exponential form. Oh, I mean, in the log form, we just look at the base in the exponent form, apply that on both sides. You get that?
Okay, okay.
It will be log applied on 2 power x to the base 2. You get that?
Okay, yes.
If you look, the log 2 is the operation, a log base 2 is the operation done on both sides. Otherwise, the original equation is kept unaltered. You get that? So we are not done.
Yes, sir.
So this will get you log y to the base 2 is actually equal to, the power can be taken to the front. That will be log 2 to the base 2. This will become x is actually equal to our log y to the base 2. So that is the conversion of this exponent form to the log form. Is that okay?
Okay. Okay, yes,
But
sir.
our target is not to do something like, our target is, can we make the base to become a
E.
e? That's the target. Do you get that?
Okay.
So let's apply the base e as the log. Is that okay? On both.
Yes, sir.
this will be log e to the 2 power x. Is it okay?
Yes, uncle.
Because just we kept the left hand side and right hand side as such from the original equation, but only log e is applied on both the side. This will help us to write log y to the base e is actually equal to x log 2 to the base e. So this one is saying this is a constant. Do you get that? E is a constant.
Yes.
E is talking to the 2, saying, come on, split yourself into e's. But if you multiply all of those e's, you should be 2 itself. Tell me how many times you split into. As both the e and the 2 are constant number valued, this is completely a constant. Do you get that?
Yes, uncle.
Okay. So now this whole thing can be written as the natural logarithm of y is actually equal to x log 2 to the base e. Is that okay?
Okay, yes, uncle.
So what is helped us to converting to up to this point? Now we can do something called we can do both kind of differentiation. There is something called, whatever the differentiation we have seen so far is called explicit in differentiation. Explicit differentiation. What is the meaning? Differentiation. What is that? If you have x squared, we differentiate straight away with whatever with respect to. This is what is making the explicit. Do you get that?
Yes, uncle.
Differentiate explicitly with respect to that particular variable. This become a 2x. Do you get that?
Yes,
But there is something called an implicit differentiation. This is actually a better way of differentiating something. Differentiate whatever the function we want to differentiate. That's it. We don't say that with respect to what. Do you get that? We want to know what is the change happening to the x. Something like if you ask what is the change happening to the x, we will say the answer is dx. Do you get that?
Yes.
This is what the implicit differentiation means. So when you ask the question, what is the change happening to the x square? Of course, it is a 2x, but there will be a change in the x itself also. Do you get that?
Yes, uncle.
Makes sense to you?
Yes, uncle.
So let's say if I ask you, what is d of e power x?
It'll be
E power x. E power x is e power
e power x. Yeah.
Multiplied by
X.
the change in the x itself. We get that?
Okay, yeah. Okay. Dx. Okay. Yes.
If I ask what is d of e power ax, what do you do?
Is it e power ax into a?
Change happened in the ax. Do you get that? Because
Okay. Yes.
that is the chain rule. Do you get that?
Okay.
So
Okay. Got it.
This
Yes.
will get all the way to the a e power ax multiplied.
Okay.
Do you get that?
Yes, sir.
Okay. Actually, when you get the answer, so now you see the d of e power ax as the implicit one. We can always take this and divide both sides by dx. You will get the.
Okay. Yeah. Okay. Got it.
You get that?
Yes, sir. Yeah. Got it.
What actually we are doing?
E by dx of. It'll be equal to a e power.
Okay. Yeah.
Okay. Yes.
This become the explicit with respect to x. Explicit with respect to x variable. We get that?
Yes, sir.
So something like that, we could, why I called that, because that is needed in our integration also, we will do very quickly. We could do that thing here. Okay. So all we need to do is find the differentiate both the sides. Do you get that? Don't call it as a particular variable. Do you get that? So this will be d of x ln 2. You're okay? Okay. So what? Tell me. Okay, we will come to that. What is actually to do with the differentiation of a natural logarithm function? But you know the answer for this, right? If I ask you what is d of, so I put a extra box here. So if I ask you, if you differentiate ln x with respect to x, this itself is a question mark, right?
Not sure.
Not sure. Okay, good. Okay, but at least tell me, can you step back and look at the function itself, what we are differentiating? Do you know mathematically what is the meaning of that function? Do you get that? This is not sure. Let it be.
Yeah.
Okay, we have to help ourselves. We cannot go back and
Okay.
revise again and because you learned it and you did it, but it could not be recovered straight away. Okay, that is good.
Okay.
Because we know that we don't need to memorize everything. Okay, so now the question is differentiation with respect to x is okay, but if I have given you something like simply a x squared, you would have answered it.
Mm.
If it is a
Yeah.
e power something, you would have answered it. But ln x is one you could.
Log is 1 by x. I'm not sure about it.
Yeah, that is okay, but think about it. Like what is the meaning of ln x? This is nothing but log x to the base e. Do you get that?
Okay. Yes, uncle.
Okay. Do you know that this is nothing but our inverse operation of the exponent? Do you get that?
Okay.
Makes sense to you?
Yes. Yes.
So all we need to do is let us do the substitution method. Let us call a new variable y is nothing but our log x to the base e. You're okay with that?
Yes. Uncle.
Okay. Now that will help us convert this into the exponent form. For that, what we need to do? We need to apply the log e is on the, because we need to convert into the exponent form. So when you are from the, what we did in the other opposite operation, when you are in the exponent form, convert into a log form, we applied the log to whatever the base we want on both the side. Do you get that?
Yeah. Okay. Yes, uncle.
So in this case, we need to do we want the base.
Okay.
Exponent form. So the base is a log e. The e is the base.
Okay.
Take both the side. This is our left hand side equal to e power right hand side. You're okay with that?
Okay.
That is what we want, right? So
Okay. Yes, sir.
y is actually equal to log x to the base e. But we don't want in the log form. We want in the exponent form. So apply the e power on both sides.
Okay.
So that will become e power y is actually equal to e power log x to the base e. Is it okay?
Yes, uncle.
So this is nothing but okay, because the e power and the log e, they are equal and opposite mathematical operation. They will cancel each other. Actually, e is saying, come on, split yourself into e's and then multiply all of them should become a x. Now tell me how many of you split into. And
Okay.
e is saying, e power is saying this whole thing is the e has to be repeatedly multiplied so many number of times. Do you get that?
Okay. Yes, uncle.
That is the reason e and log e power and log e will be equal and opposite. So this will lead us only e power y is equal to x itself. Makes sense to you?
Yes, uncle.
You're okay?
Yes, uncle.
Okay. So now we got this form. Now this is better because we don't know how to differentiate the ln x. So we got it into the form of e power y. Do you get that? Now
Yes,
apply
sir.
the differentiation on both the sides. Is that okay?
Yes.
This will be d of x. So now what is the differentiation of e power y?
E power y.
E power y, that is all done.
No. Into dy by dx.
Not dy by why you want a different variable? We are just asking what is the change happening to
Okay.
the function e
dy,
power.
dy,
One
dy.
variable is the y. We are not doing with any other variable here. Do you get that?
Okay. Yes, uncle.
Why you need a support of some variable differentiation? Do you get that?
Okay.
We are asking straight away. I know a variable which is only y, but it is appearing in the e power of a quantity. That's it. And e is a constant. This one, we are saying that, okay, the change happening to the e power y will be e power y itself, but its own power will have a change. So we need to differentiate the power itself. So this will be e power y dy. You're okay?
Yes, sir.
Okay. So straight away from here to here, we could, okay, this is a bit of a distraction, but we get that. Don't settle with the d by dx. You are okay with that?
Yes, sir.
That is a very special case. We are differentiating with respect to, but we could always differentiate with respect to any variable, right?
Yes, sir.
So let's say if I ask you a question, what is d by dA of e power ax? Why can't we differentiate with respect to a also, right? Tell me what is the answer for this? Same thing.
E-
Look, what is the differentiating from the differentiating variable point of view?
Okay, e power ax.
E power ax, because the a is appearing in the power of the e, natural
Yeah.
number. Okay, that answer is this. Then continue with what you continue with.
Will it be into dx?
Why I mean, why x is so important for you? So you don't know. If I ask you what is d by dA of e power a, you don't know how to differentiate this. You will ask the x to
That'll
come.
be e power a.
Yeah, don't you see that? Actually, you have
Okay.
a chain rule here also. D by dA, whatever this differentiating variable is there with respect to, and this is
Okay.
coming over here, and that become the 1-to-1.
Okay, yes.
That's why it is a e power a. Same thing. You need to
Oh.
still differentiate. Don't settle with. I don't know why the youngsters are taught with the numbers for so long time, and they are always want to go to number. Otherwise, they are not settling in their life. And then once they started some kind of at 12th standard or something or 11th standard differentiation, they want to always differentiate with respect to x. I don't know why. Do you get that? In this case,
Okay.
differentiating variable is the a. That means x has nothing to do with it. It is a constant. We can take that out. So the answer
Okay.
will be x e power ax. Do you get that?
Okay, yes, sir.
That is completely
Oh.
different from the previous
Okay.
answer. Do you get that?
Okay. Yes, sir. Got it.
Okay. So in this case, you don't look for I want the x. X is what? X is just the alphabet. It could be anything, right? I mean, why you are so happy with x? As long as mathematics can be done, you can use any variable, right?
Okay, yes, sir.
I don't know, Al-Karami or somebody who is the guy who first started the algebra, okay? And when he started, he just used the very first variable, which I don't know, I will call it as a x. And from there it all started. But as soon as we want anything further, we went for y, and then we started adding all the other variables in the mathematics. Similarly, when you come to the function, we said that, okay, let's the independent variable be the x, because we started the algebra with the x as the first variable. Let use it in the same way. But we could use any variable, right?
Okay, yes, sir.
So a function can be dependent on a or b or alpha or beta. It could be anything. Okay. So all we are saying, if you differentiate e power y, which is the other side is differentiation of x, simply we see from it is a differential operator. That's it. So we are asking, what is the change happening with the e power y? As the base is a constant and particularly a natural number, and power as a variable, we are going to say that this is a e power y itself, and whatever the job to be done, that same job to be done on the power of the e. That is what it is. Not with respect to anything. Do you get that?
Yes, sir.
We started with, first of all, without respect to anything. We give very implicit, open differentiation. Do you get that? So this is when the change, what is the change happening to the variable x? It is simply the change happened to the variable x is a dx. So this is a e power y dy equal to dx. Okay.
Yes, sir.
What we did in this particular case, we started by substituting the y as, so this question mark actually become a what is dy by dx. That was our original question. Do you get that?
Yes, sir.
Okay. So now, using a substitution method, we went to a point that now we have the equivalent of that particular thing in this particular form. What we requirement, we want to extract the dy by dx from here. Do you get that?
Yes, sir.
What is the dy by dx? It will be 1 over e power y.
1 by e power. Yes.
Okay. All these things was achievable because we just used the y as our ln x, which is also equivalent as log x to the base e. You're okay with that?
Yes, sir.
Okay. So now we need to find what is e power y, because the y was just a substitution in between. Do you get that?
Yes, sir.
Using this, you have how to find the y, e power y. Apply the e power on both the side. It is okay. E power ln x. Is it okay?
Yes, sir.
These two will cancel because they are equal and opposite, this will say that e power y is nothing but our x itself. Is that okay?
Okay. Yes, sir.
So that is why the answer is 1 over x.
Oh, okay.
Okay, it is not the log. It is explicitly when you differentiate, when it is particularly, it is a log to the base e to the x, then only it is a 1 over x. Do you get that?
Okay. Yes, sir.
Not any other base. Do you get that?
Yes, sir.
Any other base means we need to do the job. We need to do the work. Do you get that?
Yes, sir.
So we started with, okay, can we differentiate the 2 power x as a different problem? This was not very straightforward. We know only d e power x by dx is our e power x itself. So what we did, we tried to use a substitution, which is our 2 power x. Is that okay?
Yes, sir.
This whole problem, original problem, become find dy by dx. This is where we were. Okay. Then what we did, as we know, the e power base is a better one. We applied the log base e on both the sides. Is that okay?
Yes. Yes, sir.
Okay, I put it in the bracket to say that this is our left-hand side and this is our right-hand side. Do you get that? Equation balance should be always balanced. Is it okay?
Yes, sir. Yes.
We should not do it. So this side will become look like ln y. This side will become a x ln 2. Is it okay?
Yes, sir.
Now we are in a position that, okay, now we converted this whole thing into variable only. It is not in the, so now we can straight away apply the d on both sides. Is it okay?
Okay. Yes, sir.
So this will be d of x ln 2. Ln 2 is a constant. So this whole thing can be taken outside the, so what is the differentiation of ln y now? Tell me.
Ln y will be log of y to the base.
Ln itself is a log, Karishma. Ln y is nothing but log y to the base e. Do you get that?
Yeah, yes, uncle.
This is the first symbol used by the Napier. Okay, this is called natural logarithm. Natural logarithm. Okay,
Okay.
Also called Napier logarithm. Napier, because he is the mathematician. Here he lived very nearby. Here even there is a university under his name is a Napier Edinburgh University. Okay. Napier University, Napier logarithm. So the n, some people call that, why they call natural? Because e is the natural number. Okay, approximately 2.718 and keep going like that. Logarithm. Okay. So
yes.
We found that particularly when it is a natural logarithm of a variable, then we know that the change happened to that is nothing but 1 over the argument of whatever the natural logarithm multiplied by the change happened to the variable itself, the function itself. Do you get that?
Oh, okay.
Okay, so that is the mean. You get that? So d of ln x is nothing but dx by x.
Okay.
Okay, so now we are asking d of ln y. What is the answer?
Certainly 1 by y.
1 by y dot
dy.
Okay, equals, as this is a constant, ln 2 will come outside, you will have a dx.
Okay.
We're almost there. All we need to do is we want dy by dx. That was our original target, right?
Yes.
That will be y times our ln 2, which is a constant. What is y? Where is the substitution? It is a 2 power x.
2 power x. Okay.
So that comes to nothing but it is saying it is
2 power x.
2 power x multiplied by ln 2. You're okay?
Yes, sir.
Yes, x itself, y only is our, this was the substitution we started with. Do you get that?
Yes, sir.
So it is saying when you differentiate any constant rise to the power of the variable itself, then it looks like only thing is, as it is a exponent function, you will get the same thing, but an extra
multiplied by
log e to that base itself will be an extra part. Do you get that?
Okay, that's okay. This was the formula. Okay.
It is not a formula. You see how the function is telling us to do that. Do you get that?
Okay, yes, sir.
And then we need to differentiate the x itself, the power itself. Do you get that? That has to be the picture. You're okay?
Yes.
So in that case, let's say if I give you something like d by dx of a pi to the power of ax. Do you see that?
Okay. Yes,
We
uncle.
should
So
we
it will
should not first-
be,
yeah, you see from the x point of view, pi is a constant. Again,
yeah.
another natural irrational number, which is 3.14 and keep going. But its own power got a x. That means, voila, well and good. What we are going to do, we are going to write it as the pi power ax will be
Yes.
the answer because it is an exponent function.
Yes.
As it is not in the exponent base is not in the e, then we need a ln of pi. Do you get that?
Okay. Yes, uncle.
And then we need to differentiate the power itself.
Ax. Okay. Yes. Yes.
But that's a change because any differentiation you need to go up till you go to dx by dx. Until then it is not
Okay.
completely done. Do you get that?
Yes, sir.
So this will become a pi power ax ln pi, and a is a constant that can be taken outside dx by dx. Okay.
Okay. Yes, sir.
So that will become a pi ax ln
Lin.
pi. Okay. Is it okay?
Yes, sir.
But if it is not immediately coming into our knowledge or something like that, don't worry. Apply a
Okay.
substitution, that is pi ax power ax, then things can go very well. Okay, because we want to change the base of the exponent to a some kind of e. That is the reason we apply the log base e on both the side. We get that?
Yes, sir.
Log base e on the both the side of the substitution equation. That will make it life better. So this will become ln y is actually equal to ax multiplied by log pi to the base e. Voila. You see, this become
Yes.
this is a constant. You get that?
Yes.
And now we are dealing. So now if you want to differentiate the d by, if you can do it with the dx also, I would leave it as a d itself. Ln y is going to be d of complete the other side, ax log, or we can write that as a ln pi. Okay.
Yes.
A is a constant, can be taken out. Ln pi is a constant that can be taken out. So this side differentiation, tell me, what is the answer for the ln y differentiation?
Be 1 by y into dy.
Dy. You see, naturally that has to come. Do you get that?
Yeah.
Because
Okay.
we are asking for what is the change happening to the function ln y. Ln is a mathematical function operating on a variable named y. That means because of it is a logarithmic function to the base e, the differentiation will become a 1 over whatever that variable. Do you get that?
Okay. Yes, sir.
And then this side will become the a ln pi will be outside, and then the dx
dx.
will be there. So we want
Yes.
dy by dx, that is nothing but y times
Y
a ln
a
pi.
ln pi.
And what is the y? The substitution was pi a power x. Okay.
Pi a
That is
power
what
x. Yes.
become our the d of pi a power x over dx is nothing but the function itself multiplied by a multiplied by ln pi. Is that okay?
Yes, sir.
Okay. You feel much more, rather than staying with the formula, we need to have the as much as possible, I mean, do the complete postmortem. Go down,
Okay.
down, and everything.
Yes. Okay.
And if you do that for every exercise problem, when you are spending time on that, don't target only, okay, I will take a formula, substitute it and get an answer. That will be for that instant, it will be okay. But when it is actually required, doing some other problem, that won't click your mind. Do you get that?
Okay. Yes, sir.
So the time spent should be more useful. Like that is why I keep telling you that do it. So like I told you, like d by dx of x squared. Take even this one. Okay, I will tell you this from the x point of view. This is nothing but a multiplication between two variables. Both of them are related to that. Do you get that?
Yes, sir.
And we proceeded with something to get it. Okay. Now, can you extract something equivalent out of this? Like whenever the differentiating variable and there is a multiplication going on, then we need to deal it within a particular way. We cannot do both at a time. Even if you have 3 of them, we left 2 of them outside and differentiated only 1 of them. Do you get that?
Yes,
And
sir.
we did it until we complete all of them one by one. So when you go to the x cube or even x raised to the power of n, we did it n number of times. Okay. So now I slightly change the whole thing. Okay. Now I am going to say that, let's say we differentiate some function f of x multiplied with a g of x. This is possible, right?
Yes, sir.
Like I give you a differentiation. Can you find, let's say, y equal to x e power ax? Okay. Now I may ask, what is dy by dx? Do you get that?
Yes, sir.
From the point of view, it looks like, what is this? Y is a function of x, of course, looks like some function of x multiplied by some other function of x. Meaning f
Okay, yes.
is an algebraic function and g of x is our exponent function. This is an example case. But all we are wanting is a differentiation with respect to the x variable. So from the x point
Okay.
of view, there is a multiplication going on
Yes.
and both of them are related. So the sheep counting has to come into picture.
We
Let's
use.
make the one of them wait outside, differentiate the
Yeah.
other, and
And then add it with
other outside and
G
differentiate.
df
together.
by dx. Yes.
This is what they call that as a
The
product.
product rule. Yes.
But that is not a rule. It is actually the
Mm.
natural way of doing the differentiation. Do you get that?
Okay. Yes, sir.
Okay, so that will help us. So if you want to differentiate d by dx of, let's say, x multiplied by e power, that was the, take the e power ax. Is that okay?
Yes, sir.
Okay, that means keep one aside and differentiate the e power ax by dx and keep the other one aside and differentiate the other function. Is that okay?
Yes, sir.
Okay, so this will become, tell me what I should write.
Right. Once again, x into, it'll be e power ax into a.
Okay, keep it as simple as that. We still need to differentiate the power of the x.
Oh,
You get that? One more
okay,
extra
fine.
step is not going to be harmful for us, but it will
Okay.
make us to recall the actual process what we are doing. Do you get that?
Okay. Yes, sir.
Okay, so completely we went up to the d by dx. Do you get that?
Yes,
Because
sir.
if a is a constant that will come out, then the dy by dx by dx, whatever the differentiating thing, that to end to that last point. You see, again, this is a d by dx. That means this side is,
Okay.
we don't need to do anything further here.
Yeah, it will be plus e power
ax,
ax.
and this is a 1 to 1. Do you get that?
Yeah, 1 to 1. Yes.
I will write one more extra step. This is x multiplied by e power ax multiplied by a multiplied by dx by dx. We want to see this d by dx as to, that is the thing you are saying, that we have went all the way down to, we are interested in a change happening to a function, whatever form that is actually with respect to x, means we need to look through this guy, because this may be so much into the x. It may have x in all functional form, all mathematical operation, but in doing the differentiation, we need to go to the point where I get dx by dx. Do you get that?
Okay, yes, sir.
Okay, so this will become, now it will be a ax e power ax plus e power ax. Okay. You're okay with that?
Yes, sir.
Okay, now we could even take the 1 plus ax whole thing multiplied by e power ax. You're okay?
Yes, sir.
Okay, so now you see we took a function and we differentiated that with respect to x and we got an answer. So now we need to think about, let's say I want to recover. Let's say this is our starting point. Is that okay? 1 plus ax e power ax. Is that okay?
Yes, sir.
So look at here. I mean, if this is the starting step of the very first information about your problem, and we want to, from this, we want to recover what is this y of x itself. Okay.
Yes.
That is a requirement. And we know that, okay, integral dy will recover that, but according to the equation, original resource, this will be integral 1 plus ax e power ax dx. Is that okay?
Yes.
Do you know that because of the starting differentiation was two different function multiplied with each other, that has produced this positive or negative here. Do you get that?
Yes, sir.
So when you are doing an integration of a function, look at whether it has an additional form like this. Do you get that?
Yes, sir.
Then that means it is giving a clue as it has started with a differentiation of two functions. Both of them are related to the variable x.
Okay.
Do you understand what is the thing?
Yes, sir.
Okay, so that is the reason we go back, take a step back, think about what has happened. We differentiated this for a f multiplied with g. Do you get that?
Yes, sir.
So we had f times the dg by dx plus g times f df by dx. You're okay?
Yes, sir.
Even though it is called a product rule, what we are going to do, we need to recover. Do you get that?
Yes, sir.
Think that it is okay, even though it is with respect to some variable, write it in a more explicit form. You're okay with that? Now,
Yes.
Explicit form. Now it is in the explicit form. Implicit form will be if you are looking for a differentiation of two function getting multiplied, all we need to do is keep one aside and differentiate the other, plus keep other aside and differentiate the first one. You're okay with that?
Yes, sir.
Okay, so this will look like also the first order differentiation. Another way we can write it as a fg prime. You're okay with that?
Yes.
Okay, have you seen the symbol?
Yes, sir. Thank you.
Yeah, so this side will be fg prime plus gf prime. Are you okay?
Yes.
Okay, so now what we are going to do, we want finally the fg has to be recovered, isn't it?
Yes.
Okay, what we need to do, how to recover this? How to recover, if you know fg prime, the prime is actually the differentiation. Don't you think that we need to integrate this?
Integrate. Yes.
Okay,
Yes,
that is our, okay, I won't write, I will keep it as a fg prime. Is that okay?
Yes.
So this side will be integral fg prime plus gf prime. Okay. So this
Yes,
is
sir.
an addition that can be expanded. This, the integration and the differentiation are equal and opposite. So we will recover the fg with nothing but integral fg prime plus integral gf prime. Okay. But
Yes.
still the integral is still waiting as a, both of them are integration. So what we are going to do a bit of a rearrangement to tell that we can recover at least partial part of, because this is actually still keeping that addition. Do you get that?
Yes.
So we are going to say that if you integrate the function f with respect to the differentiation of the g, that is nothing but part of the product has been recovered as a partial integration minus the integration of the other function with respect to the first function differentiation. This is this guy. Is it okay?
Okay. Yes.
Makes sense to you?
Yes, sir.
This is what is called integration by parts. Okay, this is called the integration by parts. Is it okay?
Yes, sir.
You learned this, right?
Yes, uncle. Yes.
Integration by parts. So now look at here. So, okay, so all we are saying that, let's say we want to integrate 1 plus ax multiplied by e power ax dx. Now we need to choose in such a way that we need to, this is our original problem. It has both the f and g prime. Okay.
Yes, sir.
But we need to choose the f and g prime in such a way that everything can be taken care of that. In this, I will tell you an order in which we need to choose the
Eyelid.
yeah, light. You know that. Who said that? You already read it
In
about that?
school is I late.
I would say better use the Layet. Is it okay?
Okay.
Log,
Okay.
inverse function, algebraic, trigonometric, and exponential. Reason being,
Okay.
this exponential guy, if you integrate e power x dx, you get the same thing. Easy to integrate. You get that?
Yeah. Yes. Yes.
Okay. And then the next easy integration is the sine theta or cos theta with respect to theta will give you the minus cos theta d theta. So that is the reason all these from this side, it is the favorable for the dg. Okay.
Okay.
With
Yes.
this side is favorable for the f itself. Okay. So in this, we have an algebraic and we have an exponential. You get that?
Yes. Yes.
So the algebraic and the exponential. So obviously, we are going to say that the algebraic will go to the f itself. You're okay?
Yes.
So that
Yes.
will be 1 plus ax, and then our g, that is our dg. You're okay? dg is
Yes.
nothing but our e power ax dx. Okay.
Yes.
So the meaning is, if you multiply, so if you after recovering this, if you write it as integral f dg, it should cover everything in our original problem. Do you get that?
Yes.
That will be 1 plus ax multiplied by e power ax dx. Okay.
Yes.
Okay. So once that is done, then it's easy to get the job done, because we are going to say that integral f dg is nothing but fg minus integral g df. Okay. So what we did, f is actually equal to 1 plus ax. Definitely we need the differentiation of the f. That is, tell me what is df. We are going to differentiate this other side, 1 plus ax. Is it okay?
Yes.
That will become 1 is a constant, ax will give you a dx. You're okay?
ADX. Yes.
And then this side will become our dg, which is our e power ax dx. Now integrate both sides, will recover our g itself. Okay. So g is going to be, tell me the integration of this.
Yes, uncle. So it is e power ax
Over d by dx of,
over d by
so
dx
you get that?
of
If
ax. Okay. Okay.
if you force yourself to the formula, you are going to, I'm not saying you are going to get the answer wrong, but you are unnecessarily forcing yourself to go for a formula or what I am going to do. Do you get that? Try to get the help from here itself. It is only always any function, and then integration means differentiation of what that function is acting on. Do you get that?
Yes, sir.
Okay, so this gives us g is nothing but 1 over a e power ax. You're okay?
Yes, sir.
So now we have all of them. So we are going to say that integral 1 plus ax e power ax dx is nothing but f and g multiplied. F is actually 1 plus ax whole thing multiplied by our 1 over a e power ax. You're okay?
Yes, sir.
Minus integral 1 over a e power ax, and df is our a dx. Is it okay?
Yes, sir.
So the a get cancelled, and then we are going to say that expand this so that we can have e power ax over a plus x e power ax minus this integration will be e power ax over a whole thing plus c. Is it okay?
Yes, sir.
So these two things are exactly opposite. So we recovered our original starting differentiation. We started some time ago, the integral of 1 plus ax e power ax dx. Is it okay?
Yes, sir.
Any questions, Krishma?
No.
Okay then. Okay. Enjoy the
Okay.
rest of the Diwali. We meet next
Yeah.
week. Okay.
Thank you.
Bye.
Okay. Bye.